Hello, class. Today we begin Chapter 2, or on Lesson 1, an introduction to functions. And at the top of the page we have an illustration, a comic strip, and we read, "As a child, I was very advanced mentally. When I entered school at age 4, I had the mind of an 8-year-old. That kind of early development can be very valuable in life or in later life." And the one person answers on the side, "I'm sure." It says, "When you are 60, you'll have the mind of a 64-year-old." Okay, now that was supposed to be funny, I guess maybe for mathematicians. Anyway, let's see what we're going to discuss regarding this, and there are some relationships here, values that are related to others based on what these people are saying, and we can make certain assumptions. And we're going to use this as a basis to learn functions. How does a person's intelligence as a child relate to his intelligence in later life? From the claim in this cartoon of having the mind of an 8-year-old at the age of 4, one might conclude that such a person's mental age will be twice his physical age throughout his life. The table below shows this relationship. So here we have a table. Now we're going to be using tables quite a bit, and particularly in the beginning of the year. Physical. We have physical age. Now that's the first value, okay? And this table is going to go across horizontally. All right, and then we have a mental age. And we have values here. So we have the value of 4 and we have the value of 8. He said when he was 4, he had the mental age of 8. So if we were going to assume that his mental age was double, then when he's 5, he would have a mental age of 10. When he's 6, he'll have a mental age of 12. When he's 7, he'll have a mental age of 14. And when he's 8, he'll have a mental age of 16. And then we have these dots over here, which pretty much just telling us that you can go on and on and on, okay, and so forth. All right. You can go infinitely if you're creating this, and there are no limitations as to what values you could put in for physical age, then we could infinitely go forward into numbers so big, and we can always double it to obtain the mental age. Now, to each physical age in this table, there corresponds a mental age. 8 corresponds to 4, 10 to 5, and so forth. A mathematician would say that a person's mental age is a function of his physical age. So the mental age, okay, is a function. All right, let's write that down. And for us to know the mental age, we would have to know the physical age. And we can obviously obtain the physical age if we knew the mental age based on this this correlation or this relationship that we have between the two numbers. We know that mental age is always twice the physical age. Now, a function is a pairing of two sets of numbers so that to each number in the first set there corresponds exactly one number in the second set. So for everything that we see here, we have our first set. There's a corresponding number. So just going to write that up here. There's the first set and there's the second set. Okay. Now, one way to represent a function is with a table as was done above. Now, another way to represent a function is by writing a formula. Okay, here's another word. Formula. And as you can see, we're learning words throughout algebra. It's very important. Algebra is a universal language, yet we do use our language to actually to define what we're doing. It's very important as you go further on in your math life to understand the terminology, particularly when you're being asked to solve something or you're asked to create something. So we have a function and we see the function here, but we can create what's now called a formula. And actually, let me go ahead and write the other word right above here, that this is a table, okay? So this is our table over here. All right. Now, to show, for example, that a certain person's mental age is 2 times his physical age, we might let P represent physical age and M represent mental age, and simply write M is equal to 2P. So the formula we're going to use is M is equal to 2P. And as you can see, we're taking P over here. I'm just going to put this up here. And we're taking M out of here. Why? Well, because P represents physical age, so we took the letter P. And M represents mental age, so we took the M. Now, we can use any variables. We could have written this as, let's say, X is equal to 2Y. Again, the reason we use M and P is so that it may give us at least a clue as to what letter represents what, simply because we know that M means mental and P means physical. So, but we're not necessarily bound to use any particular variables as long as we're using different variables in this case. Okay. Now, let's take a look. And the two letters in this formula are called variables. As P varies in value, so does M. So we saw that up here. P would be 4, 5, 6, 7, 8. And as those varied, so did M. M became 8, 10, 12, 14, and so on. Okay. If we were to insert or plug in a different value, we can put in any value. In this case, they're telling us to use 15 as a value. Okay, so we're going to write 2 times 15. Notice how I'm using the parentheses, and we know that that's denoting multiplication. What is 2 times 15? Well, that would be 30. So we could actually place up here when P is 15, M is going to be 30. And we have another example. They use 25. What if P is 25? Well, if P is equal to 25, M is equal to 2 times P. P is 25. So now we would say 2 times 25 is equal to 50, which means M is equal to 50. So again, we can continue to add on to this table as long as the day is light and into the night, but we're not going to do that. We get the idea here. We don't have to go ahead and write all of these numbers. We can simply write a formula that anytime you have variables M and P, in this particular case, M is equal to 2 times P. Okay, but let's take a look now at what the other character said, because he said something different. He saw a different relationship between the numbers. We looked at the relationship here as M being twice P, okay, and we were able to create a formula that showed M was equal to 2 times P, and it showed that relationship in a mathematical sense through this equation. Let's take a look here. As the character in the last panel of the cartoon has pointed out, it is also possible to conclude from the claim of having a mind of an 8-year-old at the age of 4 that the person is merely 4 years ahead in intelligence. When we say ahead, I try to re-emphasize throughout the year that we have to understand the words that are being used so that we can turn them into equations, into expressions. So as if we're reading here that the person is 4 years ahead, well, that's different from what we read at in the top of page 66, that the mental age would be twice his physical age. So you see where the words are telling us something differently here. We're reading mental age will be twice, and here we're reading that a person is merely 4 years ahead. So that means we're going to end up using a different operation here. And let's take a look. We're going to go ahead and create just maybe a smaller version here. We have a P and we have an M, right? And if we were to use that, we have a table here to illustrate. We have 4, that would be 8, right? The physical age is 4, mental age is 8. But when he's physically 5, his mental age would only be 9, because we're just simply adding 4. We're not doubling as we were over here, 5 and 10. Now, what if he's 6? Well, he would be 10. What if he was 7? Well, he would be 11. And what if he's 8? He would be 12. Okay, and then again, so on. So, and you don't have to write that. We're just kind of illustrating this. we're just using this set of values from 4 to 8, and you can use any set of values. But what we're most interested in here is the relationship of M to P or P to M. And in this case, we said he was 4 years ahead. Okay, a formula stating that someone's mental age is always 4 years more. Okay, here's another word. We use the word ahead, now 4 years more. Before we use double, okay, 4 years more than his physical age. Well, M is equal to P plus 4. 4 ahead, 4 more, okay, versus double over here. Here we were doubling. So one of the most important things that you're going to have to do in algebra is understand the words that are being used. We use the word ahead, and we use the word more, okay? So, although it is unlikely that either of these functions is correct, it is certainly true that a person's intelligence does change in the course of a lifetime. The method by which a person's IQ is determined takes this change with age into account. So, in this lesson, we've gone over what a table is, what a function is, and what a formula is. And again, we just started scratching a little bit of the surface of taking words and translating them into the expressions or into the equations that we're going to use, the formulas. So this was a good start for chapter 2.